President, India International Center, trustees of India International Center present today, Shri Narayana Murthy, Mrs. Indumati Menon, family members of late Professor MGK Menon, ladies and gentlemen. On behalf of IIC, I welcome you all this evening for the first Professor MGK Menon Memorial Lecture to be delivered by Shri Narayana Murthy. Mrs. Indu Menon had proposed and sponsored the event, and it is the pleasure of IIC to host and organize the same. Late Professor Menon became a life-trustee of IIC in 1974. He served as president of IIC from 20th January 1983 to 19th January 1988, and again from 1st January 2007 to 31st December 2011. Professor Menon was an acclaimed physicist who had played a prominent role in the development of science and technology in the country over 5 decades. Amongst the many distinguished appointments he held, Professor Menon was chairman ISRO, member of Planning Commission, scientific advisor to Prime Minister of India. He was elected as a member of Parliament, Rajya Sabha, from 1990 to 1996, and also served as the Minister of State for Science and Technology and also Education. He was a recipient of all the 3 Padma Awards, Padma Shri, Padma Bhushan, and Padma Vibhushan. Professor Menon was intimately involved with a range of programs of the India International Center in the field of science, literature, education, culture, etc. He also supported various programs connected with the tradition and culture of smaller communities of the country. Several of his lectures have been carried in the IIC quarterly. He always found time for the center's activities. He delivered the Dr. C.D. Deshmukh Memorial Lecture on 14th of January 1984 on Indian education, the challenges and opportunities. Before I request our President Shri N.N. Vohra to chair the proceedings, I wish to remind the audience that this being a memorial lecture, there will not be any question and answer session. Thank you. I request President to kindly start the proceedings.
Dr. Narayana Murthy, the eminent members of trust of this center, Mrs. Menon, members of Professor Menon's family, invited guests, ladies and gentlemen. Director Verma has briefly mentioned about the numerous and varied attainments and achievements and honors won by the late Professor Menon. I had known him during my own period of service, after retirement, after he retired and I had also retired. And then for many years, while I had worked for this center and worked with him. As the director mentioned, notable eminent scientist who made outstanding contributions in the field of science, in TIFR and ISRO. Later on, much later when I was working with him in the arena of atomic energy, he served as secretary to the science departments, advisor to the defense minister, advisor to the prime minister, advisor to the prime minister's scientific advisory committee, member of the planning commission, a minister, and whatever else you can think about for a scientist to have done. So we will utilize this evening to remember Professor Menon, his work, his contributions, and to pay tribute and homage. Coming to this evening's program, as the director mentioned, we have the good fortune of the first Professor Menon Memorial Lecture being delivered by no less a person than Dr. Narayana Murthy. I have a very indirect but irrefutable claim on him of not having known him directly for very many years. I've known him for some good time, but I've had the occasion to work with Mrs. Murthy for many years on a project which is for the public, and I've had the good fortune of achieving some very good outcomes with her support and help. Now, it is not an easy task for me to attempt to introduce Dr. Narayana Murthy. I would say that brilliant academic career, could have gone straight into the business world at a very high salary, chose not to do so, instead joined the Institute of Management in Ahmedabad, where he did very well. And years later, he and some of his good colleagues, 6 of them, they put together an enormous sum of 10,000 rupees to set up a company which became one of the best known IT companies in the world in subsequent time. It is for no small reason that the Time magazine in recent years, a dedicated publication, called him the father of Indian IT sector. And he also has to his credit of bringing Infosys as the first listed Indian company with a revenue of over $1 billion a year. I shall not speak extempore now, but refer to, with your permission, some of the more eminent features of Dr. Murthy's attainments. He'd been CEO of Infosys from 1981 to 2002, Chairman Mentor of Infosys 1981 to 2011, Chairman Emeritus 11 to 13, and under his leadership, Infosys got to be listed under NASDAQ. He is also the originator, the author, the designer, the articulator of the global delivery model, which has since become known worldwide and has laid the foundation for the enormous success of the IT sector in India being outsourced from India. He also led the key corporate governance initiatives in India, IT advisor to a large number of Asian countries. He has served on the boards of Ford Foundation, United Nations, Institute of Advanced Study, Princeton, University of Tokyo Global Advisory Board, member of the HSBC Board, Unilever Board, Cornell University, Wharton School, Rhodes Trust, Graduate School of Business, Stanford University. He's also served as the chairman of his alma mater, the Indian Institute of Management, Ahmedabad. He co-chaired the World Economic Forum Davos in 2005. He received the 2017 Thomas Jefferson Foundation Medal for Global Innovation. He was among the 12 greatest entrepreneurs of our time, as published by the Fortune magazine. The Economist ranked him amongst the 10 most admired global business leaders in 2005. He ranked 13th among the CNBC's 25 global business leaders who made the maximum impact on society during the last 25 years. Mr. Murthy ranked among the top 10 of the Financial Times list of business pioneers in technology, first Indian winner of the Ernst Young World Entrepreneur of the Year Award. foreign member of the U.S. National Academy of Engineering, fellow of the Indian National Academy of Engineering, recipient of the Hoover Medal, Tech Museum, James C. Morgan Global Humanitarian Award, Ernest Weber Medal, Institute of Electrical and Electronic Engineers, USA, Legion of Honor from the Government of France, CBE from UK, Padma Bhushan from the Government of India. He's also received the Max Schmidt Liberty Prize. He has appeared in the rankings of businessmen and innovators, published worldwide, Business Week, Time, CNN, Fortune, Forbes, Financial Times, and so on. He's a trustee of the Infosys Science Foundation, which governs the Infosys Prize, a very eminent prize, an annual award to honor outstanding achievements of researchers and scientists across 6 categories. So, ladies and gentlemen, this is a very brief summation of Dr. Narayana Murthy's widespread achievements within the country, across the world. I have great pride and privilege and pleasure in now requesting him to address us.
It is indeed a great honor for me to deliver the first Professor MGK Menon Memorial Lecture. I thank Mrs. Menon and family, respected Shri Vohra, my friend Dr. Ashok Mishra, and other organizers for their kindness. I am grateful to respected Shri Vohra for his august presence. Dr. Menon was a role model for all of us, then young engineers, during the 60s and 70s. He remains so even today for millions of youth that aim to pursue science and technology. Dr. Menon remains a role model for all of us, not just because of his stellar scholarship, but also because he used it effectively to steer India's advancement in science and technology. I have heard him often repeat Albert Einstein's words that the objective of science education is to raise new questions, imagine new possibilities, and to re-examine an old problem from a new angle. In essence, to understand the reality better. Dr. Menon's contribution to TIFR, right from the young age of 33, is well known and well documented. He was a close collaborator of Dr. Homi Bhabha and became its youngest director at 38 on the sad demise of Dr. Homi Bhabha. He went on to head ISRO and chair several higher educational institutions, including the Indian Institute of Technology, Bombay, now called IIT Mumbai. He was a scientific advisor to the Prime Minister, a member of Rajya Sabha, and a Minister of State for Science, Technology, and Education. Folks, it is fair to say that he used every bit of his learning to advance India's leveraging the power of science and technology. The best tribute we can pay to the memory of patriots like Professor Menon is to improve the scientific mindset of our children, help them solve a few of our critical problems, and make India a successful nation in leveraging the power of science and technology for removing poverty, ill health, and other problems. We can do it by helping our children get inspired by people like Einstein, who made the stunning discovery that time is not the same for everybody. That motion of a body through space slows down time for that body, and that gravity slows down time. We can do it by educating our children using simple words about the impactful work of Niels Bohr, who had the audacity to imagine if electrons only exist when someone watches them or when they are interacting with something else. Therefore, today, I will speak on how we can make our children acquire a scientific problem-solving mindset. Friends, science is about unraveling the secrets of nature and understanding reality around us. Physics answers questions like, why is the sky blue? Why does an apple fall? Why Earth rotates around the sun? Why a rocket soars into space? Why heat goes only from a hot body to a cold body and not vice versa? Why sound becomes less intense as the car moves away from us? And why we see a rainbow? Engineering is about using the power of science to remove constraints of nature and make life more comfortable for human beings. Let me remind you the words of Edward Teller that the science of today is the technology of tomorrow. For those of you somewhat skeptical about the use of fundamental research, let me give you some examples of how fundamental research has indeed become very useful. Quantum theory, invented by Max Planck, Albert Einstein, Niels Bohr, Max Born, Paul Dirac, Werner Heisenberg, Wolfgang Pauli, Erwin Schrödinger, John Bell, John Clauser, and Richard Feynman, is what has made transistors, lasers, nuclear energy, and DVDs possible today. It is fair to say that we would be back in the 19th century without quantum mechanics. The theory of relativity, enunciated and improved by Albert Einstein in 1905 and 1915, is what makes today's global positioning systems accurate. Without this celebrated theory, our GPSs would be off by 7 miles. The PET scanners, which many of you may have used, uses Einstein's famous equation E equal to mc square for their working. I don't want to go into the details. What happens there is that a positron and an electron collide and then produce 2 photons with incredible energy, and that's how PET scanners work. Anyway, this is not the occasion for me to go into that detail. Without the work of Kurt Gödel, Alfonso Church, Alan Turing, and John von Neumann, we would not have had the computers that are so ubiquitous and so crucial to our existence today. Without the celebrated theories of James Maxwell and Claude Shannon, the world would be a dark and disconnected place today. Let's remember the apocryphal words of Michael Faraday, the inventor of electricity. When asked by William Gladstone, the then Chancellor of the Exchequer of Britain, what use was electricity, Faraday is reported to have said that Gladstone could one day tax it. For those of you who are interested more in this issue or in reading about how fundamental research could indeed become useful, I would suggest that you read the book titled The Usefulness of Useless Knowledge by Robert Flexner, the founder of the Institute for Advanced Study at Princeton, with a companion essay by my good friend Robert DeGraff, the current director of that institute. This book is about the power of fundamental research in making life better for humanity. Therefore, we have to overcome our skepticism about the so-called useless knowledge and start helping our youngsters pursue fundamental science enthusiastically. It is perhaps appropriate that we follow the British scientist and Nobel laureate George Porter. I believe he got his Nobel Prize in chemistry, if I am not wrong, who called such research not yet applied research. We want our children to understand that these most famous scientific theories were enunciated when these extraordinary scientists tried to understand the nature of reality. Why is it important for our children to learn fundamental science as well as applied science? This is a valid question. Just look around this hall and you get the answer. Electricity, the bulb, fan, air conditioner, projector, microphone, and laptop were all invented outside India. I came by plane from Bangalore, called my secretary on my mobile, watched TV in my hotel room, came in a car from my hotel to this event. That car used a petrol engine, and I listened to to music on FM in the car. My friends, we have to remember that every one of these was invented outside India. Our children deserve to invent some important stuff valuable to humanity and contribute to this world so that they are recognized and respected. Else, what is our contribution to this world as a nation of 1.25 billion people? Look at our own history of advances in science and mathematics. There were many scientists and mathematicians who did earth-shaking work during the golden period of science and mathematics in India, from 100 AD to 1400 AD. However, a few people like Srinivasa Ramanujan, C.V. Raman, Satyendranath Bose, J.C. Bose, and Ashok Sen have contributed world-class work in the 20th and 21st century while in India. The scientists and mathematicians of the golden era of Indian science and mathematics were some of the deepest and most original thinkers of the world of that period. Let me give you some examples. Aryabhatta, who lived from 476 AD to 550 AD, produced Aryabhatiya, his most influential work of that time, and introduced ideas of planetary motion, quadratic, simultaneous, and indeterminate equations. He computed the area of a triangle. He enunciated the shape of the earth, and he also looked into and spoke about the cause of day and night. Brahmagupta, who lived from 598 AD to 665 AD, enunciated rules to compute with zero, to compute squares and cubes of integers, and rules for dealing with fractions, which were absolutely revolutionary ideas at that time. Bhaskaracharya, too, of Bijapur, who lived from 1114 AD to 1185 AD, whose work in calculus predates those of Newton and Leibniz, is another illustrious role model for our children. Madhava, who lived from 1340 AD to 1425 AD, demonstrated the power of his virginal thinking in using infinite series for approximate computation of some of the trigonometric functions. My dear friends, every one of these is earth-shaking, was earth-shaking at that time. Every one of these is something of which we can all be truly proud of. These people did work second to none in the world. The conclusion is that our children of today are capable of original thinking if we create an environment that encourages such adventures of mind. There are even more important reasons why our children have to be encouraged and equipped to become contributors to solving huge problems that confront us every day. India probably has more problems facing its citizens than any other country in the world. Our huge population is a big burden for providing our children basic education, basic health care, basic nutrition, and basic shelter. The Human Development Index, developed by the Pakistani economist Mehboob ul Haq in 1990 and later improved by other experts in this area, uses three parameters. They are life expectancy index, that is life expectancy in years at birth, education index, expected years of schooling or college at birth, and income index. This income index is one when the per capita GDP of a country is $75,000 US, obviously on a purchasing power parity basis, and zero when it is just $100. In fact, these parameters, in effect, tell the whole story of how well a nation is developed. The health of its citizens, their productivity, their education levels, their accomplishments, and their contributions, the success of a nation's education system, its healthcare system, the nutrition of its children, the standard of living of its citizens, its industrial and employment systems, and the adaptation of modern tools of progress by the citizens of a country. It is widely used all over the world to measure how well a country is progressing in making the life of its citizens better. India has remained around 130 in the Human Development Index ranking of nations among 193 nations in the world for most of the last 5 years. This is obviously something that elites like you cannot be proud of. We have huge problems in almost every area. We are ranked even lower than most South Asian countries and most African nations in public health. Our primary education is in a sorry state. PISA, Program for International Student Assessment, is a set of tests conducted under the aegis of OECD. All of you know OECD. PISA ranked India 72nd out of 74 countries that participated in PISA in 2009. Instead of finding out why we were performing so lonely, the UPA government found fault with the test and boycotted it in 2012. The current NDA government has realized the folly of such a decision and has decided to participate in the PISA rankings from 2021, 4 years from now. Therefore, the message is very clear. We are not ready. Our agricultural productivity is very low compared to developed nations. After the Green Revolution ushered in by Dr. Swaminathan, we have not done much to handle the saturation of soil due to certain soil nutrients we have been using for almost 50 years. Our water resources are scarce, and we have to find novel methods of providing water for agriculture and for our drinking. Our ports are very inefficient. Our cities are polluted. Our progress in reducing carbon has still not kept pace with China. The slums in cities are increasing due to migration of poor, helpless people from rural areas to megacities in search of jobs. The traffic in our cities is unimaginable. Traveling from one part of the city to the other part is a nightmare. Well, let me stop here and just say we have huge problems. I'll just drink a little bit of water and then oops. Now, what is the solution? I believe that we can find appropriate solutions to our problems if we educate our children and youth to think independently, to find scientific and technological solutions to our specific problems, make our bureaucracy much more responsive, and make our schooling and college systems totally autonomous. Let me concentrate on just the first problem in this lecture. The first and the foremost problem we have to tackle is orienting our education towards problem solving. Unfortunately, our current education system focuses our youngsters towards just acquiring knowledge and passing the examinations. We would do well to remember the words of Carl Sagan, that science is a way of thinking much more than it is a body of knowledge. There is no attempt by our schooling and college systems today to assess whether our students have acquired skills and independent mindset to recognize the problems around them on a proactive basis and to solve the problems that they see around them. No wonder that various studies show that hardly 15% of the students that pass out of our engineering colleges are fit enough for the job. I would hazard the same guess about our science students. The first task for the educational planners of India is to focus on using scientific theory to understand natural phenomena around our children in their primary and middle schools. The current system where neither our teachers nor the students understand the science that is being taught in the schools should stop. We should select about 2,000 to 5,000 natural phenomena around us and teach our children why it is so, why the nature is like that, in each science subject and mathematics subject, in physics, in mathematics, chemistry, and biology. Let me just take the case of physics and explain this a little bit better, because my knowledge of chemistry and biology is zero, and my knowledge of physics is infinitesimally small, but still I know it a little bit. The other day, I was invited to a very well-known school in Bangalore for their graduation day. I requested the principal, a very kind man, if I could attend a class first and then have an interaction with the students after the class for half an hour before I delivered my lecture. The principal very kindly agreed. I attended the class and found that it was a monologue by the teacher. This is the best school in Bangalore, please. About Newton's third law of motion, delivered with zero interaction between the teacher and the students. When one or two bright children wanted to ask some questions about how rockets work, all of you know that it is Newton's second law that tells us how rockets work. So children wanted to know how rockets work. The teacher snubbed them right in front of me and asked them not to disrupt the class. I'm sure many of you have gone through that experience. After the class, in my interaction, I found that barring one or two students out of 60, none had understood the significance of Newton's third law and its applications. I asked the students a very simple question. I asked them why the sun is red and yellow when the sun is rising in the morning or setting in the evening. Nobody could answer. Let me assure you, these are children. They will go to various IIT, they will go to Institute of Science, All India Institute of Medical Sciences, they will become very fine chartered accountants, you name it, and some of them will go abroad. But none of them could explain. However, when I probed them, they could reel out their answers to my questions about scattering of light, about Weber-Guyot, that's a component of white light, about prism experiment, and wavelengths of various components of white light. They could reel out. But somehow, they just could not connect these learnings to understand why the sun appears red and yellow when rising or setting. I sat down with them and I explained to them that the light from sun traverses larger distance in atmosphere during morning and evening, since the sun is at horizon, than when the sun is overhead. I also told them that rays with longer wavelengths are scattered much less than rays with shorter wavelengths. I further explain that sun's light gets dispersed into VIBGYOR when it hits the atmosphere, and that red and yellow rays having longer wavelengths do not get scattered like the blue and violet colored rays that are scattered by a large amount in the morning and in the evening. I said, so blue and violet colored rays just do not reach us at that time. So then I told them, that's the reason, my young friends, why we see only red and yellow rays which reaches from the sun in the morning and in the evening. So my friends, the right way of teaching science to children in school is to explain the wonders of nature using theory of science and ask them to analyze other natural phenomena using the theory that is taught in the class. There are two requirements for changing the teaching method. First is the availability of such critical thinking books in our vernacular languages. We must encourage teachers of science and mathematics at IISc, IITs, ICERs, and national laboratories to write books in various Indian languages to explain probably about 5,000 natural phenomena around us that can be explained by physics, chemistry, biology, and mathematics. Of course, many people argue that mathematics is not science. But anyway, I don't want to get into that argument today. So, each of these questions must be based on the natural phenomenon that can be explained by theory. And that's how we should teach scientific theory to our children. They should also hold summer schools for the teachers to reorient these teachers to this kind of teaching and problem solving. There are several books in the West that use scientific theory to explain natural phenomena and that help children think. Before our authors are ready with such books in Indian languages, it is a good idea to provide such books from the West to our teachers to help them assimilate this new kind of teaching. There are many Western books that will help our teachers get oriented to teaching children such a critical thinking method. I myself have used some of these for teaching science and mathematics to my children. They have done reasonably well. One went to Harvard, did his PhD there, another went to Stanford. Anyway, that's not important. Let me mention them. One book is called Thinking Physics, Practical Lessons in Critical Thinking by Louis Carroll Epstein. This is a wonderful book. Any of you, if you can get it from Amazon, please do read that. It's excellent. It's just probably about 500 natural phenomena, and it explains the theory behind that. And the second one that I can quote is Conceptual Physics for Parents and Teachers by Paul G. Hewitt. These books are excellent examples of such a genre of books. Brian Cox and his co-authors have written several excellent books simplifying scientific understanding of nature using basic physics. One of them is called Universal, A Journey Through the Cosmos and Forces of Nature. My friend Jayant Narlekar's book, The Lighter Side of Gravity, is a delightful masterpiece in communicating complex ideas in a simple way. I mean, this man is just extraordinary. One of the, I'm going out of my lecture right now. One of the questions he asks us is, have you ever seen sun rise in the west? And he explains how you could see that if you are flying from London to Chicago, in the night, and then if the speed of the plane exceeds the speed of the rotation of Earth. Anyway, I don't want to go into the details, but the important point is Dr. Jayant Narlikar's book, Lighter Side of Gravity, is just a brilliant book. But it is a little bit advanced for high school students. It's probably for college students. And imagine somebody explaining under what circumstances you can see sun rising in the west. Anyway, I can add several names to this list, like Paul Nahin, a very famous professor at Princeton University, Max Tegmark, another wonderful theoretical physicist at MIT, John Gribben, all of you have read his books, Paul Davies, all of you have read his books, and many others. Some of these authors are perhaps advanced for primary and secondary school children. I accept it. But they can ignite the minds of school and college teachers and college students. Let's remember that Einstein's capacity to do amazing thought experiments was inspired by Aaron Bernstein's multi-volume book called Naturwissenschaftliche Wuchsbücher. I cannot pronounce German properly. It's in English, it's called Popular Books on Natural Science. A story in the 16th volume of this series of books about traveling with electricity through a wire is supposed to have inspired the 16-year-old Albert Einstein to create a thought experiment of traveling with a beam of light. We know that these thought experiments became a defining feature of Einstein's thinking. YouTube provides many popular science videos that explain some of the most important scientific and technological inventions and discoveries by well-known scientists. Jim Al-Khalili, Brian Greene, Brian Cox, and Carl Sagan are some of the well-known names that have demonstrated a rare skill in communicating the most advanced scientific concepts in a simple way on TVs and videos. I don't know how many of you have watched Jim Al-Khalili's video on Einstein's theory of relativity. It's just unbelievable. They communicate advanced concepts of science by telling us arresting stories about science. That's how we should teach our children. Folks, this is how we can kindle the interest of our children in science. However, only those children in India that are comfortable in English and have access to the internet can benefit from these books and videos today. Hindi, with 370 million native speakers, is not even in the top 30 languages used on the internet. According to, not me, this is not my opinion, according to Mr. Sundar Pichai, the CEO of Google. Let me tell you, other Indian languages cannot be any better. This asymmetry of access to science arising from lack of knowledge of English must be addressed by policymakers soon, else we may unwittingly without wanting to, hold back the progress of majority of Indian children. Of course, we must write in our, all these wonderful things in our Indian languages. I have already talked about it, but it's going to take time. But in the meanwhile, we cannot give up on English for our children. Can our policy makers provide full subsidy to create a library of about 1,000 such books and videos in the various Indian languages, in each area of science and mathematics, so that it is available in every school in the country? Can they obtain permission from the relevant people to get these videos and books translated to Indian languages and circulate them to every school in the country? Can they ensure that teachers are trained to develop an appreciation for using these videos and these books in their classrooms? Second, the school examinations in science and mathematics should focus on questions whose answers explain the natural phenomenon. This is much less relevant to mathematics than science, that have not been covered in the class. I would rather the teacher asked a question about nature that the teacher has not covered in the class, but he has taught the theory and some other natural phenomena that depends on that theory, and the teacher should ask another natural phenomenon which depends on the same theory. That's how you can assess whether our children have indeed understood science, have indeed focused their mind on understanding the nature around them, and I can assure you that in another 20 to 30 years, this nation will be second to none in inventing things like the West has done. Such an examination system will help our children develop their curiosity, their independent thinking, and their problem solving. Such an approach will also help these children to become much more research focused or curiosity focused. Third, it's a good idea for science academies in India to hold competition amongst school children, particularly rural India. It's very, very important, not just in some metros, to form teams and find solutions to problems that we confront every day. The other day, I was at the New York Academy of Sciences to cheer my friend Ted Turner, the founder of CNN, Professor Venki Ramakrishnan, Nobel laureate in chemistry, and Indra Nooyi, CEO of PepsiCo, who were awarded the honorary membership of the Academy. I was lucky to be amongst the audience when school children presented their solutions to making inexpensive B12 vitamin tablets and inexpensive clean water production, among many other such interesting solutions. Interestingly, these children were from different economic strata, from different parts of the world, including India. And they were given just 4 months to come out with their solutions as a team. The children used Skype to collaborate. They were given travel grants to come to New York and present their solutions. I believe, my friends, we too should adopt such practices. We can start off with state-level competitions and then perhaps move on to national-level competitions. Such competitions give our children confidence to try out their independent thinking and find solutions to our critical problems that I talked about earlier. We must be patient because results may not come soon. It may not come to this generation. It may not come in the next 25 years. But they will definitely come. Maybe to our grandchildren. But let me tell you, the fact that this generation attempted to do this will make our grandchildren stand proud of us. As somebody said, any civilized society is one where its citizens make every sacrifice needed to ensure that the quality of life of the next generation is better. I think we must focus on that. Now, let me come to college education in science, mathematics, and engineering. We have to make classrooms much more oriented towards discussions rather than monologues by the teachers. We have to encourage our teachers to spend most of the classroom time answering the queries of students. Students should be encouraged to read the class material before coming to the class and use the classroom time for getting their doubts resolved either through the teacher or through their cohorts. There should be bi-weekly tests that assess the understanding of the student regarding the applicability of the theory to real-life situations. These classroom sessions should be supplemented by what in the US is called sections. Cornell calls it sections, where bright teaching assistants answer the questions of students. There should be laboratory hours dedicated to students applying the theory learned in the classroom to verify some of the natural phenomena. Questions in the semester examination should be open book type rather than one designed to encourage learning by rote. The biggest challenge in making this happen is training our teachers. The college system, aided by the state and central government, should invite teachers of IISc, IITs, ISER, and universities abroad to hold summer schools to train these teachers in various subjects, as I spoke about in the case of children, school children. My friends, this exercise may appear expensive. But let's remember the words of Derek Bock, a former president of Harvard University, who said, "If you think education is expensive, try ignorance." Another problem we have in our system is the boredom that sets in the minds of bright students, since our classes tend to be common for the bright, the average, and the dull. It is a good idea, therefore, to create honors versions of each course, at least in well-known institutes of higher education, in science, engineering, medicine, and law. In these honors version of courses, as it's done in various US universities, I used to be on the board of Cornell, so I know Cornell does it, the syllabus should be about 2 to 3 times the normal version. The examination should be much, much tougher, and the level of interaction by the students much higher. Such a scheme will achieve the dual objective of helping the less prepared students get their degrees without penalizing the really bright ones. This scheme, as I said earlier, has been in operation is in several well-known US universities. Undergraduate research is an important component of college education in the US. We should adopt this practice and provide opportunity to our college students to work in teams with graduate and doctoral students to hone their independent thinking habits. I have seen freshmen from US universities work with doctoral students and gain a lot from such interactions in knowledge, curiosity, independent thinking, and most importantly, self-confidence. These suggestions, my friends, are very tough to actionize, but I believe that we can do it. Because I have always believed in the adage, a plausible impossibility is better than a convincing possibility. The results may be slow in the coming. What is needed is openness to learn from people, countries, and cultures that have performed better than us. After all, let us remember Louis Pasteur's words that science knows no country, because knowledge belongs to humanity, and it is the torch of knowledge that illuminates the world, the entire world. To be open-minded, my friends, we should first be humble. We should shun our enormous ego. We need to stop going back to our ancient history and saying we are great because our ancestors were great. I quoted some of the earth-shaking work done by our ancient scientists and mathematicians, and I am very, very proud of it. Let there be no doubt. But I don't argue saying because they were great, we are great. As all of you know, we are measured by what we are today and not what our ancestors were once upon a time. Just like our ancestors made the stunning invention of zero to take a huge leap in arithmetic, never done by anybody else in the world. Can we hope that an Indian child, educated and working in an Indian scientific or educational institution, will grow up to make a mind-boggling discovery, like Niels Bohr, who postulated that the location of an electron becomes certain only at the time of observation, and that the inherent nature of reality is fuzzy. Will one of our children contribute to science like a little-known Irish theorist, John Bell, whose mathematical and experimental vision, and like a graduate student, John Clauser, whose design of an experiment proved that the mathematics of quantum mechanics and Niels Bohr were right, and that Albert Einstein was wrong? Can we produce many scientists like C.V. Raman, Ashok Sen, and Satyendranath Bose, all of whom studied only in India? Can children educated entirely in India and doing research in India emulate Chandrasekhar, Hargobind Khurana, Venki Ramakrishnan, and Manjul Bhargav? Let me close this talk with the words of George Bernard Shaw, that those who cannot change their mind cannot change anything. So, the seminal task of planting problem-solving mindset in our children will only happen if we are humble and more open-minded, if we leave science education to science experts rather than to bureaucrats, with no disrespect to any bureaucrat, and if we embrace new ideas from more advanced societies that have achieved a lot more than us. Such a transformation of our mind will make India a respectable player in the global science and technology arena. We can then solve our problems as well as the problems of the world. Friends, this is the biggest tribute we can pay to Professor Menon's memory. Thank you.
On behalf of everybody present here this evening, on behalf of the Center, on behalf of Mrs. Menon and the family, I would like to extend a hearty vote of gratitude and thanks to Dr. Narayana Murthy for speaking to us in such simple words and so passionately for what we have failed to do as a free country for the last 70 years. This question of imbuing our children, our youth, particularly our students, with the capacity to think for themselves is, I am sorry to confess, I have been associated with at least the administrative part of governance for many years now, that none of our schools, very few of our colleges, and perhaps very limited number of our universities are capable of doing or delivering what Dr. Murthy has just mentioned. On the contrary, as he mentioned in one classroom, when a particular student wanted to ask something, the teacher snubbed the student saying, "Don't interrupt." We have basically this kind of syndrome, this kind of situation all over the country. In the state where I am working, there are other factors which impede the academic schedules, which impede the curricula, stoppages, interruptions, disturbances. Children are very bright. But Murthy Sahib, I think one aspect on which you have been a little soft, you said we retrain our teachers. We are not producing teachers. We don't have the kind of teachers who will teach our children in schools, in colleges, even universities. Besides the fact that we have more than 50% of the vacancies, so-called opportunities, are lying vacant because candidates are not available. We appoint teachers on temporary basis. After 10 years, they still remain temporary. Then there are agitations to make them permanent and so on. So this goes on and on and on. I think he has pointed to one of the very crucial, vital areas of our deficiency, what we need to do, how we need to get worried about it. Now, one of the observations Murthy Sahib made was regarding the usefulness of our starting district level competitions, state level, bringing them to national level. I have been toying with this idea within the state and seeing we can do it. It has not so far fructified. But in view of my association with this institution, I would be separately requesting Murthy Sahib for his help and his support and his giving us one or two good people for the IIC to try to organize as a first ever, if not a national level competition, then at least a quasi-national level competition. All the investments, Murthy Sahib, we will make, but with your help on how to go about it, because I don't think we have the expertise of organizing even this kind of. So to sum up, the main lesson or the message we have received today is to transform our educational curricula, our systems, our academic schedules, to imbue our children to develop the capacity for problem solving, and then individual children or groups of children to be encouraged and enabled, supported to actually do so, as is given examples of United States. So with these few words, ladies and gentlemen, I would once again thank Dr. Murthy for his traveling all the way, and talking to us in such lucid, simple, and telling words. And I'm sure that many of us will be worried after what we've heard from him. Thank you very much.